In question 9, they ask you to prove that there are two similar triangles, which is ABC, are similar to triangle BDC. First, it's difficult to handle two triangles like this. They are not in the same direction, and also they repeated each other. So you better draw separately. We are talking about ABC is this shape, and they are saying that this is similar to another triangle BDC. So we just draw a smaller one with the same shape. Just now we say the triangle ABC. Therefore, for the smaller one, the order should be also the same, like this. Therefore, BDC. It's much easier to handle and also understand what the situation. So now we are going to write down any information. They say angle BAC is equal to angle CBD. So of course it should be, right? So these two angles are the same. We already proved it. Now we are write down any same angle after that. So this one is repeated. So both of them are point C. Therefore, we know that this angle is equal to this angle. It's because of common. It's enough for us to calculate. So first part, we write down angle BAC equal to angle CBD. It is given information. After that, we know another pair, angle BCA is equal to angle DCB. This is because they are common angle. Don't mix up the definition of given and also common, okay? After that, we can say that these two triangles are similar already. Triangle ABC similar to triangle BDC. The reason is because we prove two pairs of angles are the same, so the rest must be the same also. Therefore, we have a not very common reason in your textbook, but it's also correct, which is AA. 2 marks will be given for part A. Now we focus in part B. This graph is really useful, especially in part B. They say AC is 25, so we have 25 here. The BC is 20, BD is 12, and then they ask you, is triangle BCD, is this a right angle triangle? And don't forget that BC are repeated, so a common side, so also this line is also 20. It's obvious that because we already proved that they are similar triangle, we are going to use their constant length ratio. 25 to 20 should equal to 20 to DC. So you can get the length of DC. Therefore, you have all three sides, and then it's easy for you to prove is that right angle triangle or not. Our target is to find out DC first. So we use the length ratio. This to this should equal to this to this. Therefore, we write down 20 to x should equal to 25 to 20. So 4 times 20 is equal to 5 times x, both sides times 4x. Therefore, x is 4 times 20 divided by 5. X is equal to 16. Now we already know this is 16. Then we have to prove is that right angle or not. Some of you may be really rushed to write down 12 square plus 16 square equal to 20 square. Don't do that. You have to imagine you don't know whether they are equal. So what is important is you should consider BD square plus DC square. You use these two shorter length square add together, and then we try to compare with BC square later on. So we just separate that. We consider this part first. We pretend that we don't know they are the same, and then we calculate separately. 12 square plus 16 square is give you 400. After that, you consider BC square is equal to 20 square is equal to 400. Oh, amazing. I don't expect that they are the same. So it's because BD square plus DC square equal to BC square. Therefore, you can say that it's right angle triangle. It's because they say explain only. So this is strong enough. But if they use the word proof, then you have to write down the reason, converse of Pythagoras theorem.